Functions? What?
Functions.
What's a function?
Function.
I mean, is this math?
No, it's a function.
It's a function.
Is it
But
math?
isn't function math? Let's talk about what are functions today. First off, your learning target today. We will identify functions by using ordered pairs, tables, mappings, and graphs. Okay, those words sound math, for sure.
Math. They sound math.
They sound mathematical.
They sound mathy.
They sound mathy. So at least we're getting somewhere. A function assigns one output to each input. Well, what's an output and what's an input?
I could talk about eating and the output of eating, but...
Well, yeah, you eat one thing, you get one output. I mean, it works. But in math, we have an input. We put something in. We receive...
So like an X value maybe?
Like an X value.
Okay.
So our inputs are X value. We receive one...
Oh, it's almost like independent and dependent.
It is. Our independent is our input. Our dependent is our output. That's our Y value.
Sounds like it works.
It does work.
Very mathy.
It is. So an example. This is actually an example with a mapping. This is called a mapping.
Don't get overwhelmed. Let's cover this up so you don't look at that right now.
So this is an example of what an input is. We said that the definition of a function was assigns one output to each input. So does 2 have one output? Yeah. Does 3 have one output?
Yep.
Does 4 have one output?
Yep.
So that means it's a function. Now let's look at this one. Does 2 have one output?
Yeah, it goes, yeah.
Yeah. Does 3 have one output?
Yep.
Wait, but they're the same.
Yeah, but the output is the same. But the
Oh,
input
I have
only
to
has
have
one.
input to an output.
Right.
It doesn't matter if it's the same output.
Right.
And then 4 goes to 8. So again, what about if I had something? I'm going to add one in here, Miss Green. That looks like this. 1, 2, 3, 2. Would that be a function?
Yeah, because that only has one output. That only has one output. And that only has one
So
output.
all that matters is that my input has one output.
Right, so as long as there's only one line coming out of each of these, it's a function.
Okay. Sounds pretty easy to me. Let's look at something that's not an example. So 2 goes to 3 and 4. That means it has 2 outputs. Remember, if I put one thing in, I get one thing out. That gives 2, so that is not an example. But, Ms. Green, why isn't this one a function?
Because even though this is 2 separate numbers, on a graph,
It's the
same number.
Oh, and it's got 2 separate outputs. So
Right.
I have to be careful to make sure they don't trick me.
That was tricky to me. I totally would have fallen for it.
I probably would have too. But you got to be careful. Check your numbers. Okay? So let's look at some more mappings. Are these functions?
Let's take a look. Oh,
So
yeah,
what?
no.
That's not a function. Why not?
Because the 7 has 2 and the 10
7
has 3.
and 10 have multiple outputs.
I know I'm going to do something kind of weird that you might
Okay.
disapprove of. But if it was the other way around, and we're looking at these numbers as inputs and these as outputs,
Would it be a function?
it would be, because I
would.
would have a 10 to a 10.
Uh-huh.
So if the arrows were going the other way around,
It would.
and my numbers were right side up, which they're not. But I just thought, oh, look.
It would be a
It
function
would
the
be
other
a
way.
function. It
yes.
would be the other function, but not this way, because
Because
2
you're
are coming out
yes.
of this number and only 1 can come out of it.
Yeah.
Yeah.
Is this a
I just
function?
thought of something funny. So, like, if you are a twin sibling, you are not a function.
If you're a twin, you're not a function.
But
Sorry,
I'm a
Tyson twins.
But I'm a function because
I'm a function because it was, yeah.
that was one output.
I was one output. That's funny.
That's kind of silly.
It is kind of silly. So our twins, all of our twins, they're not functions.
Yeah, I'm sorry.
sorry.
Damon. What can I say?
Yeah,
You're not a function.
not a function.
Not a function.
Okay. Oh, the Tysons
If you
aren't
ever
even in
get
this video.
pregnant and you
Man.
have twins, you can say, it's not a function.
It's not a function. I love it. That's awesome. So we have this one here. I've got a 6 that goes to my 2. Okay, so it only has one output. 7 only has one output. 8 only has one output. 4 only has one output. So yes, it is a function.
It's way more funnier than it is. I'm still laughing about it in my
Miss
head.
Green is giggling about the twin thing. Okay, so how about this graph? Is this a function? Well, how do I know?
Ay, ay, ay. Ay, ay, ay.
Well, we know this is my x, this is my inputs.
Uh-huh.
And this is my y, this is my outputs. It has to be, wow, I don't even know what I wrote.
It says output.
Output.
Okay.
Promise. Output. Basically, when we talked, I don't know if you talked about this with your kids, with linear relationships, I talked about how it has to pass the vertical line test.
I don't think I did, no.
Which the vertical line test basically is something that if I stick a vertical line anywhere in here, it'll only hit 1 point because it's got one output for each input. So let's look at this. Do you happen to have a ruler or like?
Of course, I'm a math teacher.
Yeah, and is it clear? Perfect, I love it. So if I have a ruler, this is going to be my vertical line. Well, at this point, how many did it hit?
1.
Okay.
1. 1. 1. 1.
So it's a function.
It's a function.
Does it matter that this one is way out here?
Nope.
It's still a function. Function. Did you guys know functions are fun? Ha. I had to throw that in there for you. How about this? I mean, I don't think that looks like a function.
Well, let's do the vertical line
let's do the
test.
vertical line test. Let's go across.
1,
Well,
1, 1, 1, 1, 1,
I mean,
1,
this is
1
looking pretty
here.
good.
1, 1, 1. Yep.
Oh, it's totally a function. Function, because it's fun.
Very cool.
Okay, this next one, oh man, those are kind of crazy looking.
Yeah.
So this one here, we've only hit one right here.
Mm-hmm.
We're going to see if Miss Green's dots line up at all. Only one here. 1. 1. Ah, I hit 2. So it is not a function because
Not a
I have
function.
2 outputs for this input here. Not function because of these right there. So now, and I was kind of hoping it would be a function with the circle, like if this one was over here, because I was going to show you guys it with the dots. It would have been, but then if you drew the lines, it would definitely not be a function.
Mm-hmm.
But just things you got to look for. Now on this one, let's see.
I don't even have to do the vertical
I don't even
line
have to.
test.
I mean, look
see
at
the
that. I have a straight
right
line.
there.
So that is not a function.
And now let me tell you, remember, these are man-made graphs. Like, I just hand-made them.
We're not perfect.
And this, you might be like, what's not even a straight line? Well, it's supposed to be.
It's supposed to be.
Quit making
Deal
fun of
with
my
it.
lines.
Yeah, deal with it. So that's how you tell on a graph with the vertical line test. A table. Now, with a table, we've got to be careful. We got to look. It's got to have how many inputs for each output?
Only 1.
Okay, so I'm going to make sure all my inputs are this, different. So 0, 2, 3, 4, 7, 9. Are any of them repeating?
Nope.
So that means each one has a single output.
So at this point in time, on a table, do I even have to look at the output?
Not really. I just have to make sure the inputs are all different.
Okay, and they're all different, so I'm good.
So that's a function. Now on this one, are they all different?
Nope.
Nope, 1 repeated itself.
So did 2.
2 repeated itself. 0 and 3 are good. But that means it's not a function. And guys, this is pretty easy. It's just
easiest
like the
thing.
easiest thing we've done all year.
We haven't done any math.
No, we haven't.
I mean, we're doing math.
Right.
But actual, like configuring or whatever.
Okay, so ordered pairs might get a little more complicated because it's not right next to each other.
What I would do is I would go and underline all my inputs.
Yeah. So I've got a 2. I've got a 3. I've got a 4. Uh-oh, I have a 2. And uh-oh, I have a 3.
Yeah, so
Oh,
that's
that's not a function. Notice how all I'm looking at is my x values because that's my inputs. Because for each input, I have to have one output. Now let's look at this one. 2, 7, 10, -3, 0.
all different.
All different, so it's a function. I know some of you guys might be going, but what if there was one I didn't know about? Well, it's not in the set. So, I mean, we're being asked.
These little crazy lines right here, it's called, it's a set. So
Yeah.
this is it. There's no more.
Yes, so I mean, that's it. You don't have to worry about what's not there. One other little thing I wanted to show you guys really quickly. The way that you notate a function, some of you guys have seen this, some of you probably haven't, is this little notation here. f of x. That means it's a function. You guys are probably like, where have I seen that? Miss Green, can I borrow your calculator?
It's not on my calculator.
Oh, it's not?
It's on theirs.
It's on theirs. Oh. So in your calculators, when we hit that y equals, instead of it saying y equals, which you guys were always confused.
This one says y equals.
Let me fix it.
Is there a way to do it?
Yeah. Instead of it saying y equals, let me see if I can figure it out.
I've seen it on some calculators.
Oh.
We'll just show you in class.
We'll show you in class. But instead of it just saying y equals, it usually says f of x. I don't know if it is these calculators anymore. Now I have to think about that.
Oh, well, it's okay.
But this is called function notation. And when you see it, it just means the function of x. So like if you see f of, let's go, x minus 3, that means y equals x minus 3. So I made a mistake right there. Just ignore my little mistake. Anyways, we are out for today. That's functions. See you later.